All right, guys, what we got here today is we got us LB7 Duramax, and customer's complaint was losing coolant. Don't know where it's coming from. So when he brought the truck in, he had his degas bottle was black, and that tells us it had combustion in it. So we put a pressure test gauge on there, and the truck was building 30 psi on the coolant pressure system, which is too high. So we got into it. Somebody had previously done a stud job on this truck. It did have ARP studs, but if you look here at this gasket, you can see all the blown out spots. And the reason for that could be possible they didn't machine the heads, or what we found on these gaskets, this is not an OEM gasket. This is a cheaper version that you would find at like a, like an aftermarket supplier. I don't even think it's Melee. I really think it's Victor Renz from years ago. They put out some gaskets. A lot of the Ford Power Stroke 6.0 owners got attached to these too and had a lot of problems with them. So I believe our culprit is the gasket that was used and possibly the deck surface on the head. So we're going to correct those issues by putting OEM gaskets, and we're going to machine the heads, and we're going to go through and put new cups in the heads and do all that and put it back together properly to where we know it's going to hold, stay together and not have these issues and maintain normal coolant pressure. All right, so what we got going on here is we're going to set this head up, we're going to level it, and then we're going to machine it. If you can look closely, you see all these surfaces. You can see where the gaskets were blown here really good. We're going to take this and make sure it's perfectly flat when we're done. So we got to level. We're going to level it in 8 points to make sure we're perfectly level, and then we're going to lock it down, and then we're going to start the machine and cutting process. So stay tuned. Right now I'm just touching the surface just to know where my pointer's where I'm gonna level, that it's nice and clean, so I'm getting accurate measurement. So we're gonna start trying to level this head out. This has to be precise, or the head's not gonna be cut evenly. So this is where the time comes in. The time in head cutting is not the head actually cutting, it's actually setting the machine up to cut the head. Right now we're still in the process of just getting our head as flat as possible across the 8 points to make sure the head's level before we attempt to cut it. And I'm going to make sure I'm at 0. See, I'm still at 0. So now that from here to here is level. Now I got to do here to here, here to here, here to here, and then I know it's all level. Then we can start our cut. But you can't think about cutting it until this is all right. All right, so we got our head level now. So next step is to get our these lock the head in place, the plate, so it doesn't vibrate or anything, and change our measurement that we've got it set at. So it just holds the deck in place. So now what we're going to do is we're going to move our machine up, and we're going to start setting up to cut. And I'm going to do some shortcuts. As in shortcuts, I mean some very light cuts, so I can show you the warpage in the head, and so you'll be able to see how it's going to cut here, it's going to stop cutting here, and it's going to cut here. Basically what it tells you is it's warped here, and this is the reason why we cut heads, is because if somebody just takes this head off, cleans it up, puts it back on, more than likely it's going to blow again because your surface isn't flat and even. So let's just add a couple, we're just going to add a couple thousandths here, and just that way you can see the warpage. So I just added about 2 thousandths. So with our machine on aluminum, we got to add a little bit of olive oil. That keeps the metal from getting stuck to the head. And we're going to soak it down, and then we're ready to rock. So watch what happens here. So if you look from the top, if you look from the display view, it only cut here, and then it cut all the way on the other side on here. And so my head's level, but this is all warpage. So now we've got to add more to it to get more cut off. So, and typically I wouldn't do that. Typically I would measure the warpage here versus here, and that's where I would start. But just for video purposes, I wanted to show you the difference and how much warpage we got. So I'm going to add another thousandths, and we're going to see what we cut this time. Okay, we're getting a little further this time because we're cutting a little more. Each thousandths we add, we're going to get more. we're going to add 2 thousandths more because the last 2 passes were 1,000 each. Obviously you can see it made a little difference, but it's not making a huge impact. If you come look over here, you can see it cut a little bit more here, a little more here, a little more here, same on this side. So we're just slowly starting to dig into it. So now we're gonna put a little bit more to it. We're gonna dig in a little deeper here. Another question you may be asking yourself is how much can we take off this head before it becomes an issue? Well, I'll explain that to you too. So what we do is we take calculation of what gaskets came off the truck, and then there's 3 different gaskets that they offer for the Duramax. The one we always use is a C grade gasket. It's gonna be the thickest gasket. So depending on how much we take off the head and how much, you know, it's kind of tough in this situation because this one has already been done, so I don't know if they cut this head before, but I'll be able to check my valve depths and determine if it's within reason, if I can make it work. But what GM does is they use different thickness gaskets depending on where these valves sit in the head. So a truck could come with an A gasket, a B gasket, or a C gasket. C gasket's the thickest, so that's going to give you the most room for to prevent interference. So that's what we're going to try to do here, is get it as close as we can, you know. But at some point, if you get too far with cutting the head to get it cleaned up, we may have to send the head out to have the valve sunk. That way there is no interference even with the C gasket. So we'll determine that once we find out how many thousandths we have to take off this head. Usually if it exceeds 8 to 9 thousandths is when you have to send the head out, but it just depends on which gasket it had originally. It depends on which gasket you're using, and it depends on, there's a couple different factors. So you just got to do the math and figure it out to make sure you're not going to run into a problem. So we're going to go ahead and take 3 thousandths on this run. So you ought to see a large difference in this last run and this run, but you can see we've done about probably 3.5 thousandths so far, and we've got almost the front and the rear cylinder. Now we're lacking here to here. So hopefully this 3 thousandths will take the rest of it out, but we're fixing to see. Yep, so here's your finished process. The deck's at 0. This one did measure out of spec. We had to cut too much off of it to get it back even because of the customer driving around too long with blown head gaskets. So we're going to have to send it out, have the valves sunk, but once the valves are sunk, he'll be ready to rock for another, 100, 200, 300,000 miles, however long it lasts. But I'm sure the head job is going to outlast the bottom end. So, but the head's good to go now. And obviously all the metal shrouds and stuff, we're going to put it through the parts washer. We're going to clean it and all that stuff. But when they redo they're going to do the valve stem, sink the valves and everything, get us back in spec to where we have 0 interference.